Alright, this is just a quick demo to show how I built this QAVR, a crash I had, and how to kind of repair some of the carbon fiber plates if you damage it. This is a clone QAVR 6-inch, running these RS205s, which I love, little Bs, and pretty much got a SP Racing F3 board with deluxe with the onboard OSD. It's a great little board. It does chew a little bit of power, so watch out as far as that. But mainly what I want to focus on today is the receiver. So a little trick that I learned from YouTube is basically have these couple zip ties coming out vertically, well, horizontally, but you know, they stay away from the props. You can run the antennas through them, put a little shrink wrap around it, and then it keeps them nice and stable, even with a crash, right? You're not going to get them cut, because the last thing you want to do is brush something, have a propeller cut it, and then you lose telemetry or your transmission. I believe one of them's telemetry, one of them's receive, so you want to be careful with that. If possible, split them out as much as possible, but in this case, this has been working pretty well. So I'm going to show a couple videos of me flying around, running clean flight with Luxfloat. Luxfloat is pretty cool PID management algorithm. Been very smooth compared to the multi-rewrites, easier to tune. Anyway, so I was doing a lot of dives and rolls and very low, you know, to the ground flying, you know, and it was just doing perfectly until one of the flights I was running pretty low on a corner, and I basically caught an edge and it rolled it. I checked for damages. There wasn't really anything wrong, maybe a broken zip tie, but took it up again, flew it around a little bit. But on the next pretty steep dive, I was doing about 400 feet. I was doing a vertical dive, which it was before has been doing pretty well. It lost signal, you know, maybe 200-300 feet up, and basically disarmed and lost all connectivity to the controller. So only thing I can think of is that the UFL connectors came a little loose, and the vibration coming down basically pulled it off or popped it off just enough to you know, crash the quad. Failsafe didn't work appropriately, but you know, at that speed there's pretty much not much it could have done, right? So it was hit the ground pretty hard. You know, face first on the GoPro. I got a little GoPro mount. Mount was fine, but the carbon fiber had sheared off, and at the back actually broke the base plate here. So what I did is I recut both plates with 2 mil, and I'm gonna actually show you that later. But this is the original, which is about 1 or 1.5 mil. You know, got rid of some of the weaknesses in the design, like these little dog bones. So I'll show you what I did to basically put the pieces back together, scan it, and cut it on a CNC, and get it back up and running. So the only other thing to say is make sure you test the range, and make sure you test the failsafe. You know, the Tyrannuses have great telemetry, so you can actually take the receive signal strength from the drone itself, make sure that it's communicating both ways. If there's any issue, definitely try to figure it out. Upgrade the antenna if you can on the Tyrannus. I've got to put an RBSMA so that I can change it to a patch if I want to do any long range stuff, but for the most part this little Omni does quite well. So from there I'll show you a couple of videos and then how to repair the crash. and something to do with signal. So lost the signal about on the dive, but I don't see any damage to the antenna, so probably the vibration kind of pulled. You can actually see that there, this was chipped. But anyway, good times. Alright, so what I did is I just threw it on a regular scanner, and basically took a high-res scan of it, of both the top plate and the lower plate here, as you can see. And for the most part, it's pretty good. The problem with scanning is that you're going to get these, you know, see if I can get a little closer here. You can kind of see that the holes aren't perfectly circle. So, you know, and there's a couple things that I want to remove, like for instance these parts up here, these little dog bones that hold the little side plates. I don't use them, and that's kind of where it broke. This was I believe a 1 mil or 1.5 mil plate. I'm just going to get rid of all these excess holes to kind of stiffen up you know, this brace, because the front is going to take most of the impact. I'm going to widen these a little bit as well, so that you know, the side where the straps go for the battery, that way it's a little easier to thread it. And then similarly on the bottom plate, I'm going to remove the excess stuff. These bottom dog bones, just get rid of them. I'm going to add an extra set of holes over here. This bottom part is the front of the quad. It didn't crack. What cracked was actually right here. So not really much we can do to reinforce. I kind of want to leave these holes for some ventilation for the transmitter and LED. The LED is consuming a little bit of wattage, so it gets a little hot. And then you know, just clear up these holes, make sure that I've got a good template. So basically what I'm going to do is I'll show you the process. I basically just fire up Gimp, right, and this has already been done, but I'll show you, you know, just create a new one. Just close it out, and then I'll just drag the raw image. So you know, you basically drag in this into Gimp. I like Gimp, and then from Gimp I go to Inkscape. So you may be able to see the contrast, but you can kind of see it's all carbon fiber looking. We kind of want to remove that. So what I'll do is I'll kind of get in close, and then you know, you can kind of see the stencil or the pencil, like, you know, to create a circle. We want to increase that size so that we get the right sized hole, right? And then you just basically click and you just basically clear out those holes, make them nice and perfect. You know, you get the idea. So you do that all around, and then when you're done, you know, just click it here, make sure they line up. If you want to add any extra zip tie holes or straps, it's also a good time to do it. I think I added some extra zip holes for the transmitter, the video transmitter, because it was a little loosey. So you know, you can kind of see now that these holes are a little bit clearer. And once you're done with that, you know, you can clear out some of the shadow. There's easier ways to do this, but this is just the fastest way. I know how, and it works pretty well. So once you're done, what I usually do is use flood fill. I kind of change the threshold much higher, so that when I fill it, it basically makes everything carbon fiber black. So you're not going to see that, you know, the grain. So this is the with the grain, and this is just basically flood fill, so that it's nice, just black, right? And then go back in with the pencil and fill out any of the white little traces or specks that may cause a problem with the cutting. So you can kind of see like this popped up here. Let's get rid of that. Makes it nice and clean. So that'll get you the raw image, and I'm gonna get rid of these dog bones because I just want the extra strength, and I'm not really using them. So, but you get the idea. And at the end of the day, when you're done, you'll have, let's see, so this is the completed one here for the lower, and then I've got the upper raw here. So you can kind of see that now that I've got two pretty good templates to get started. And then next thing you do is you basically just import them into Inkscape. So you pull up Inkscape, and I'll just do a new one just to kind of show you the process. So right now these are images, right? So you can go ahead and print them if your CNC supports it, but my CNC is XCarve, and it only does SVGs. So we've got to basically get this into SVG format. You can copy paste or just drag and drop, right? Whatever's easier. Once you're done with your Gimp, right? So this is the Gimp file that we had modified. We basically can save it as a JPEG or whatever you want to do, because by default it's going to save it as the XCF, which is the proprietary format. I'm going to go ahead and file, export as, save it as a JPEG, and then in here, in Inkscape, we're just going to take that, that lower one, or whichever one we're working with, and this here is the image, right? You can always look over here at the object properties. On the right hand side, it'll say it's an object, right, of type image. So it's not going to do much. Go ahead and scale it, with the little ruler on the left hand side, and select centimeters, millimeters, whatever you're into. Test it again, 140, looks good. Okay, now we're going to go ahead, click it, path, trace bitmap, and then now you will see the actual rendering, right? So I basically do it as minimum as possible. You can kind of increase it. So threshold, brightness, cutoff. You can do edge detection, but that'll just get you the outline. I do brightness cutoff, and then you basically just increase it until you see all the holes disappear, and you can kind of see that there's just a little speck there. But once you do that, click OK, and now you've got a vector-based representation, right? This one over here on the left is the image. You can kind of overlay it, make sure it's right, but for the most part, we're just going to get rid of the image. So let me close this. So now when you click on this object, that it should be a type path. Then we just go ahead and go File, Save As, and then you change it to a plain SVG, give it a name, and now you are ready to cut it. So I'm going to skip over to my CNC. My XCarve setup, running a DeWalt. I've got a 2mm carbon fiber plate. You can kind of see I've already cut out one plate, but I'm going to cut out a second top and bottom just for backups, and maybe to make a second frame for my other one. Cutting carbon fiber, a couple ways to do it. You either do it in a dish of water, if you do a shallow pan, so you can kind of catch a lot of the dust. I've got this pretty nice, I believe it's called a suck-up dust boot but it works exceptionally well to kind of keep all the carbon fiber dust clear. And I'm using a 1/16 4-flute bit. It does nice smooth cuts, so that's kind of where we are. So let me show you the software. You can use pretty much any software that you're comfortable with. I use Easel because it's easy and it's free. So you go to File, you import SVG. So we can go to QAVR. Let's do upper, and you can kind of see now that we've got this in place. You'll see there is a measurement on the side. It's the top plate's 160 millimeters, so it's pretty much accurate. And then what we want to do is set the parameters, right? So your z-axis is going to be about like 2.2 millimeters, but I'll set it to like 2.1. And by default, if you kind of see on the right side, if you can make it out, it's basically just going to cut holes where the darkness is, right? So what we want to do is set outline and set path to outside, and then now you can kind of see that. Okay, here's what it looks like, and it's going to cut around the object. And I can zoom in a little bit to make it a little clearer. And then you can also see that when you select this object, there's depth of cut, and then a couple of these tabs. So these tabs are helpful to keep the pieces from flying around once they get cut out. It's all set like 8 or something. And then you can kind of drag and move these tabs so that any piece that's getting cut out isn't going to go flying and potentially jam up or get caught in the bit as it's cutting. So probably would need one more on this piece here. So that should be pretty good, and it should be enough to cut. Spacing, length of these little tabs, don't need anything crazy. 3 millimeters and 0.2 height. Carbon fiber is pretty hard to cut by hand, so you just want it to hold in place, and then use a file or a small snippers to kind of get those pieces out. And since I'm trying to get the most out of this plate, I'm actually going to run it horizontally. So you kind of move it to where the next bit is, and you can kind of see it's going to be about here. I know it's about 60 millimeters wide, because if you see the bottom plate, I cut just about here. So just to be safe, I'm going to run it there. So once we get that in place, you basically choose your bit. I'm going to use a 1/16, and the preview will show you that there's no red marks. There's a couple here, like you can kind of see that it may be getting a little close, but go ahead and cut it anyway. It'll be good enough for government work. So then we go ahead and you can simulate it to kind of see the tool path. But essentially at that point, you'll be able to cut that plate. So I already have the lower set up already. Couple things is I changed the material to PCB. You can probably cut it faster, but I'm doing 255 or 254 millimeters a minute with a plunge rate of 228 and a depth per pass of 0.4. That seems to be pretty safe and successful on this part. So at that point, we can go ahead and start the cut. So what I'm going to do is just kind of lower this down and kind of show you that process. So first thing we've got to do is home the machine to make sure that we have our XY correct. add a little battery to the GoPro. It's running a little short. So we're not going to put the dust boot on yet because I want to make sure it's properly homed. So now that it's homed, we can go ahead and basically, you know, if you're familiar with the software, you already know that you've got to home it, secure it, and there's a pretty good tutorial and step-by-step on getting it set up. But what you want to do is just find the right point where the bit is just touching the carbon fiber, so that it's a good cut through. The last thing you want to do is have too much gap, and then you have to recut, or it's horrible. Anyway, so I basically dropped the bit down until it touches the carbon fiber. You can actually see it move a little bit. It's still got the protective coating on it. So once it's you know, going, once it's ready, you basically raise the bit, and then I'm actually going to raise it a bunch more again and move it out of the way. Now I attach the boot. Nice and secure. Lock it down. This is a pretty good boot. Definitely worth the money. I don't think it was that expensive. I'll post a link to where I used it, where I got it, and from then on I am going to do the cut and then show you the result. So let me turn on the shop vac to gather the dust and you know, have it ready to go. Pretty much finished, so all that you gotta do is just you know, get it out of the way and check your part. You can see pretty much, aside from the little corners that ran into the other cut, you pretty much have a good copy that matches up pretty nicely with the original, you know. So that's pretty much how you do it. And then just take your quad apart, put the plates back on, and you're back and flying. So that's about it.